Hi, I'm Michael Killen. I think climate change has advanced to the point we should start to think about what are the most important things we should do to slow it down and minimize the great impact it's going to have on the world. So I am searching to understand and identify, let's say, the three greatest threats of climate change, and I'm also producing shows and other things to try to identify the most important solutions to address those particular threats. I've invited Dr. Steve Zornetzer to be a guest on this show. I'm going to ask him a series of questions about a nonprofit where he is co-chair of the board that I tend to think is his organization is addressing the most important threat of climate change. Steve,
how are you, Michael? Very good.
And you and I met when you were the #3 man of NASA Ames, and if I understand this correctly, you were in charge pretty much of all research at that gigantic NASA facility, right?
Yes, I was the Associate Center Director for Research and Technology at NASA Ames for a number of years. And in the course of that job, I was responsible for overseeing all of the research and technology development at NASA Ames.
And did you get involved with some of the NASA programs testing or making observations in the Arctic, Antarctica, and the Arctic and Greenland?
Well, NASA Ames was responsible for a program that NASA runs that was enabling research in the Arctic. So we were actually managing the aircraft and the instruments and things that the scientists used to take measurements in the Arctic for many, many years, yes.
Has that experience, or having observed what NASA was doing, helped lead you to now being on the board of ICE 9/11?
Well, indirectly, yes. When I retired from NASA a few years ago, I was looking around for interesting things to do, and I had remembered that I had heard a seminar many years before when I was still at NASA by a Dr. Leslie Field, and she was looking at the possibility of manipulating ice in such a way that she could increase the lifespan, the longevity of ice before it would melt. And those data were quite preliminary. She reached out to me, and her organization reached out to me after I had retired and asked if I would be interested in hearing an update on what they've been doing in the subsequent 8 or 9 years since I had originally heard their preliminary data. So I said, sure, that sounds quite interesting. So we met at a coffee shop, and she opens her computer and she starts showing me all of the results that she's been collecting with her team, the ICE 911 team, over the intervening years. And when I saw the data, I was very impressed with what they were able to do. They were able to increase the longevity of ice in places like Minnesota, on lakes in Minnesota, in the Sierras, and even up in Alaska by a significant amount of time. So the reason this is important is because, as we all know about global warming, we can see on the news, almost every day, some impact of climate change and global warming. We can feel it ourselves at times. These fires, the wildfires the past few years in California are another manifestation of global warming that impacts all of us and impacts the planet. What most of us don't know is that the Arctic is warming twice as fast as the rest of the planet. And this has very serious amplification consequences for global warming in general.
Can I interrupt you?
Sure.
I can sense where I am in Menlo Park, Silicon Valley, the climate is changing and warming. I can feel that. And now you're telling me that up in the Arctic, it's warming twice as fast?
Twice as fast. The Arctic is extremely sensitive to global warming for the following reason. And that the scientists have given this a name. It's called Arctic amplification. The Arctic Ocean, which covers most of the area of the Arctic, above the Arctic Circle, if exposed to sunlight, when the sun shines 24/7 during the summertime, that dark Arctic Ocean water absorbs a huge amount of heat from the sun. For the last 700,000 years, the Arctic Ocean has never been exposed during the summer to sunlight because it's been covered with ice. Over the past 50 or 60 years, that ice is melting more and more in the summertime. As it melts, it exposes the dark Arctic Ocean waters beneath it. When those waters are exposed to the sunlight, remember 24 hours a day the sun is shining up there during the summer months, that Arctic Ocean water is absorbing 90% of that energy of the sun. When it's covered by ice, it's only absorbing about 6% of the energy from the sun. Well, because we're losing our heat shield, the planet is losing this heat shield in the Arctic.
The heat shield is the ice.
The ice. It's been there for 700,000 years, and and the Arctic Ocean waters have seen very little sunlight until the last 50 years. And actually, since 1979, 90%, this is an astounding number for the viewers, 90% of Arctic sea ice, the volume of Arctic sea ice, has been lost in just 40 years.
Wait, 90%?
Actually, it's 95%.
95%
yep.
of the Arctic ice?
Of the volume of ice.
The volume.
So the ice used to be, 50, 60 feet thick.
200 feet thick.
200 feet thick. Yeah. Well, now every year, most of that is gone. And now there's very little multi-year ice left in the Arctic. And what you're seeing over the winter when it refreezes after the summer ends is you're seeing what's called seasonal ice, which is very thin. It's maybe 2 or 3 or 4 feet thick, not hundreds of feet thick. So we've lost that volume. The Arctic Ocean is absorbing a tremendous amount of energy. And something that most people don't know, we think about climate change as being the result of greenhouse gases, carbon dioxide, methane, other gases that trap heat in the atmosphere and warm the planet. It turns out that because of this Arctic amplification effect and the Arctic Ocean warming so quickly because the ice is melting, that now the amount of energy that's associated with global warming due to the absorption of the sun's energy by the Arctic Ocean, now that's contributing a total of 40% of the total global warming that's occurring. So 60% is still due to greenhouse gases, but 40% of that is due to the loss of ice and the increased absorption of energy by the dark Arctic Ocean and the land that's being exposed as well.
Can I paraphrase you? Because this is new to me. So right now, 60% of what is causing greenhouse gas emissions is coming from us and other natural causes.
No, 60% of all global warming is due to greenhouse gases, of which we're producing most of it.
Okay. And the other 40% is coming from the melt of the ice, which has warmed the water up there. And now that the sun is hitting it many, many more hours a day, that's heating the water.
So it's heating the water, and the water then heats the atmosphere above it. So the climate in the Arctic is warming. That's the Arctic amplification effect, and it's also, as the ice melts, there's called an ice albedo feedback loop. So albedo is a technical term that scientists like to use. Basically, it means reflectivity. So when you go out in the sunlight and you're wearing a dark sweater versus a white sweater or a white shirt, the white shirt will reflect much more of the sun's energy, yes, and you'll feel cooler than if you were wearing a black shirt or a black sweater.
Sure.
So the same thing is true with ice in the Arctic. As the ice covers the Arctic Ocean, it's reflecting a very significant amount of the solar energy.
And then all of a sudden the water becomes exposed, the water is dark, the water brings down the energy, absorbs the energy.
It absorbs 94% of it instead of just 6% when the energy that's absorbed when the ice is there.
So, you know, I think after meeting you and thinking about the ice, I came to the conclusion, as you know, I'm not a scientist, but it seems to me the melting of the Antarctica, Greenland, the Arctic, and that melt and the impact it has on the weather, the impact it has on other aspects of, makes the melt of ice the greatest threat of climate change. And I don't know, you're a scientist, does that make sense?
Well, I wouldn't, I'd say it somewhat differently. I'd say the loss of ice is significantly accelerating climate change. And if we can find a way to prevent the rate of loss of ice, if we could cause ice to persist over the summer months and continue to reflect the sunlight as opposed to melt and expose the dark waters, then we have a significant chance of impacting the 40% of climate change, which is due to the warming of the Arctic. The other 60% is still a big problem, and we'll talk about that. But if we can move a lever, that 40% is a big lever on the total amount of climate change that's occurring. If we can slow that down, if we can cause ice to persist longer, and we'll get back to Dr. Leslie Field's contribution to this problem in a minute. But if we can do that, then that can have a tremendous effect on slowing down the rate of climate change. And we'll talk a little bit in a minute about why that's important. So let's go back to Leslie Field and what she did. She thought about this problem. She was a material scientist. She's got degrees from MIT and UC Berkeley. And one of her degrees was in material science. And she's patented a number of materials in the course of her career. And so she thought about this. Well, why is the ice melting so quickly? Well, it's absorbing a lot of the sun's energy. Well, how can we slow that down? How can we prevent that? How can we change the albedo, increase the reflectivity of ice?
Put something to block the sun.
Well, that's one possibility, and that's perhaps a little bit more dangerous to do because we don't understand all of the unintended consequences of doing that. But what if we could simply increase the reflectivity of ice and slow down the rate with which it melted? So she looked around for materials and possibilities of, what if we spread something on top of the ice that increased its reflectivity? It absorbed less energy from the sun. It melted more slowly because of that. So she started doing some small tests in the backyard with different materials. Fast forward a number of years, and she discovered a material, a manufactured material that already existed. You can buy this material, that when spread over the ice, actually increases its longevity very significantly, maybe 30 or 40%. What is the material? The material is very, very benign. It's like sand, little beads of sand, but they're manufactured. They're very bright. They reflect a tremendous amount of the energy from the sun, the light. They're hollow with a little gas bubble in the middle, and they float on the ice. And they get incorporated into the ice structure as the ice forms. So this material helps the ice reflect much more of the sun's energy. They're non-toxic. We've done a number of biotoxicology studies on a number of species. We all have evolved, all animals on the planet have evolved in the presence of silica, sand. And that's basically what this is. It's sand, but it's manufactured. And so it doesn't harm animals. It doesn't harm the water. It doesn't harm fish when if fish were to ingest it, or polar bears were to lick it off the ice. Doesn't hurt them. So it's non-toxic. It does work. We've done studies now in the Arctic, in Point Barrow, Alaska, where we've demonstrated on football field-sized test beds with controlled test beds associated with that.
What did you discover? We
discovered that the ice persists for about 30 or 40% longer into the melt season than if we hadn't put those beads there. Oh. So now the point is, if we could do this at much larger scale, in the Arctic, could we prevent or slow down the loss of Arctic sea ice into the summer months so that the amount of energy absorbed by the dark Arctic Ocean waters is much less?
What's the significance of slowing down, pushing back the ice? What's the significance to us?
Well, you know, climate change is accelerating much more quickly than most scientists, than the United Nations International Panel on Climate Change have ever predicted. They predicted we had much more time to solve this problem than we're learning now that we actually do. Things have accelerated much more quickly, in part because I don't think anyone really understood this Arctic amplification effect. And now they do. And they realize that climate change is due to more than simply greenhouse gases. Now it's because of the Arctic is melting and the Earth is absorbing, the planet is absorbing so much more energy from the sun than it did when the heat shield, the ice heat shield, was present. So now things are moving very quickly. And if things move so quickly and we as a species, humans, can't adapt and reverse the effects of climate change on the planet, the consequences are dire. There will be huge swaths of land that people now inhabit and use to feed themselves that will become deserts. There will be other portions of today's land all along the seacoasts that will be flooded as sea level rise occurs, as the ice melts in both the Arctic and the Antarctic. I mean, the Greenland in the past few years has shed about 500 million tons of ice each year in the summer months. That's just one little Greenland is 500 million tons of ice a year is being lost due to climate change. And that's directly causing sea level rise. So sea level rise will accelerate. Extreme weather will accelerate. The fires that we've been seeing is extreme weather. The floods and the hurricanes in the Gulf Coast states, that's extreme weather. It's all a product of climate change. It causes billions of dollars a year in damage. It further hurts our environment, and it threatens people's lives.
And you think it's going to get worse?
It's going to get much worse if we don't do something about it.
Much worse. And this solution, putting these little beads covering part of the ice in the Arctic, and you put it in the water. So you don't put it on the water. It floats, so you could put it on the water. We think it's much better to put it on existing ice, for example, in the spring, just before the ice melts. If you coat that ice with these beads, it buys time for the ice to persist much longer into the summer. And if we can do this in critical places in the Arctic, and we've been working very closely with modelers and modeling and simulation activities, using supercomputers to model climate change as a result of our interventions. So you can test various hypotheses using this modeling and simulation approach to say, well, if I did this, if I changed the albedo of ice by so much at certain periods of time, what effect would it have on the climate? And through the numerical computations that the supercomputers do, they can predict what the results would be. Sometimes they're right, sometimes they're not so right. It depends on the accuracy of the model. So you have access to supercomputers
yes.
to do your modeling. At the same time, you've also done physical, real tests.
Yes, both.
And you've got results that the ice sort of recedes, or the melting stops, slowed down.
The melting is slowed down. So we actually use the data that we collect from field studies to inform the modeling.
Sure.
So we work hand in hand with the modelers. And we're also collaborating now with NASA as well. There's something called the NASA Earth Exchange that ICE 911 is part of, where we're actually using NASA supercomputers as well to help us with these calculations and trying to get collaborators around the world to work with us to extend the impact of our modeling.
Now, I've read ICE 911, the nonprofit that you work with, has enough money to maintain a presence in the Arctic for 8, 10 years. Is that correct?
No, I mean, we've struggled over the first, we were a startup, basically, and Leslie Field started this group a number of years ago. And so for any startup, it's a struggle with money. So the first years, everything was being done on a shoestring and, you know, homemade equipment and everything else. We're at a point now where we're really beginning to attract enough attention, bring in enough resources that we can be much more professional and large scale in our field study work in the Arctic. Let me tell you what our goal is. I mean, our goal, we will never, we ICE 9-1, will never solve this problem. What we want to do is demonstrate the effectiveness of our methodology at large enough scale so that places like the United Nations, the United States government, the US military, Arctic nations can look at our data, see our results at a smaller scale, and say, okay, we believe this is going to work, and now we, the United Nations, or we, the Arctic, you know, consortium of nations, will do this over, you know, 40% of the Arctic.
Yeah.
We'll do it at scale. That'll cost billions of dollars, but nations can do that.
Yes.
And the cost avoidance of doing that
It's trillions.
is huge.
More than trillions.
Huge. And just ask the insurance companies what they've spent on the fires in California alone. It was $16 billion last year. That's just California, just for fires. And then there's the flooding from the hurricane. I mean, you know, coastal flooding. So the cost avoidance is well worth this.
So you're thinking now about a very, very large implementation of this technology.
Yes.
And you've already done some small.
Yes.
And now you're thinking about much larger, and you'd like to get some good data back, and then you're going to look to do 40%.
Well, with some number. Some, you know, I'm not sure what the right number should be yet.
Now, this will take a lot of money.
Yes.
And do you see where this money's coming from?
The money for ICE 911 to do this, or for the larger scale?
For your next?
For our next deployments?
Yeah.
Yeah, I mean, we've been very fortunate. We seem to have a number of very generous donors that are contributing to us, and I would invite your viewing public, if they're interested, go to our website, www.ice911.org, look to see what we're doing, what we've done in the past, and there's an opportunity, if you're interested, to contribute to ICE 911.
Yeah, I didn't hear the website. Would you repeat it for me again?
Yeah, so just www.ice911.org. Just Google that, and it'll bring you right to the website.
So you are going to the UN, to NOAA.
We spoke at the UN this summer, actually, yes.
Yeah, and other European Union and others,
yes.
And you're pointing out that, you know, we are going to be hit. I mean, we are being hit already by the impacts of climate change, but we haven't been hit at all compared to what's coming.
That's right.
And ICE 911 has a solution that can give us more time.
Buys time.
Buy time before these other gigantic, the hits like the fires get even worse.
That's right.
And maybe we can find other solutions that, like putting a tax on carbon, that would, and doing something to protect the oceans from chemical changes. And am I articulating it?
Yeah, so I mean, let's talk about that part of it, because I think that's really the most important part long term. So we talked about the 60%, 40% part of the problem, and we're addressing the 40% part of the problem. The heating, the additional heat that's being absorbed by the poles because of ice melt. The other 60% is a continuing problem. I mean, right now, humanity, since the Industrial Revolution, has put in 400 gigatons of carbon into the atmosphere. 400 billion tons of carbon dioxide into the atmosphere. Currently, there are about 1,500 billion tons of carbon in the atmosphere. And we've added 400 just since the Industrial Revolution. The others are from natural causes. There's always going to be carbon dioxide. There always has been. Yeah, or, you know, volcanoes, fires, natural fires, other things. But since the Industrial Revolution, where we started burning hydrocarbons for energy, you know, coal and oil and gasoline, we've added huge amounts of carbon dioxide into the atmosphere. That's what's trapping 60% of the heat these days. We're still adding 40 gigatons, 40 billion tons of carbon every year as a species. 40 billion tons. We have to stop that.
Yes.
That's number one. We have to stop adding to the problem. That's going to be a huge effort to get off a carbon economy worldwide and start using renewable energy. Then there's still the problem of the 1,500 gigatons, billion tons of carbon that's already in the atmosphere. We have to start taking that out if we're going to restore the planet's healthy climate to what it was even 100 years ago. What if we could just roll back the clock 100 years in terms of a healthy planet? We would not in terms of our technology. We'd actually be advancing our technology in order to do that. We'd be creating jobs in order to do that. We'd be rethinking how we do things, how we use materials, how we reuse materials. Those are all part of the 60% of the problem that we still have to address. And that's what we want to buy time for humanity to do, because these are hard problems.
Okay. We have a minute left. What category of solution would you put your solution in?
Climate restoration. We want to restore the climate.
That's a new one. I mean, normally we deal with sustainability, resilience, mitigation, and
right. This is a new one. Climate restoration.
All right. It's new to me. Could I put it under the as a subcategory of resilience?
Yes.
If you're quick, you say, you know.
Yes.
Yours is, resilience is to be able to spring back from the hits, and you have a solution. ICE 9/11 has a solution to help us become, the climate become more resilient.
Exactly.
Okay. All right. Ladies and gentlemen, my guest has been Dr. Steve Zornetzer, and he is on the board, the co-chair of ICE 9/11, and they are looking to invest heavily in a solution that may help save us lives, millions of them, and billions and trillions of dollars in our infrastructure. Thank you very much. I'm Michael Killen.
Thank you, Michael.
I thought you were fine, more than fine. And I just...